Okay, let's finish our 1.5 module, which now we will be graphing the inequalities. So the thing with inequality is you have infinitely many solutions, meaning it's not just that one point that we have to graph and that's the answer. We will be having infinite solutions for that. So for example, if we say x is greater than -4, okay, so then any solution that is more than -4 will be the solution for x. So if this is -4, now it says greater than -4, that means -4 is not the solution, okay? But any number that is more than -4 will be the solution for it. So what you do is as your answer or as your graph, you just draw a line, okay? That tells that all these are the solution for your inequality. Now, because -4 is not the solution because it says greater than -4, so you leave this dot empty and we call it open dot. Now, another thing is this one says x is less than or equal to 1. So this is your 1 and it says anything that is less than, okay, will be the solution, but it also says that it's less than or equal to. That means 1 is also the solution for it. So you fill the dot, okay? And when you fill the dot, you call it closed dot, okay? So this is how you graph the inequality. Now, some of my students told me what tricks they use. So they say when this is pointing to the right, then you go to the right, okay? When this is pointing to the left, you go to the left, okay? And when it's equal, then only you fill it, okay? When you don't have equal, you leave it open, okay? Now, how do we write our inequality using the interval notation? So we just learned how to graph. Now we will be learning how to write using the interval notation. So for this one, okay, first let's graph it. So this is more than, so again it will be going this way, okay? So then if you have to write its interval notation, then interval notation is you either use parentheses or use square brackets. If you have the more than or equal in equal, that means that is the endpoints are the solution, so you use the square brackets. But if, like in this case, if you don't have the equal, like we are just saying x is more than -4, then in that case we will only use parentheses, okay? So this is the endpoints for this one is -4 and it is going towards infinity. So it's this endpoint is -4 and it doesn't have any endpoint, that means it's going towards infinity. Infinity, we do not know where it's ending, so we always use parentheses. And in our case, because -4 is not part of the solution, so we will also use the parentheses. Now let's take a look how you will do this one. This one we said it is starting at 1. We will fill it because it says less than or equal to, and then we will be going to the left, okay? Now in this case it does not have the left endpoint because it's going towards negative infinity. So we will say negative infinity, and then this endpoint is 1. So since we do not know what is the last endpoint for infinity, so we always put parentheses for it. Now this 1 is also the solution for your inequality, so you will be putting the bracket for it. Okay, this is how you graph it. We will do more practice on it. So let's graph these and also write down the solution for it. Okay, so this one, A says x is less than 3. So this is your 3. Now there is, it doesn't say it's equal, there is no equal. So it only says x is less than 3. That means we will be leaving it open and we will be going to the left. Now interval notation, so it's this endpoint, the left endpoint is again it's going towards negative infinity. So we will put negative infinity, and its right endpoint is positive 3. Now we use parentheses for infinities, and this one is not part of the solution, so for that also you put parentheses. So this is how you write down the interval notation. Let's do B, and B says x is greater than or equal to -1. So this is -1. We will fill it because it says equal, and we will be going to the right because it says more than -1. Now interval notation, our left endpoint is -1 and our right endpoint is positive infinity. So there is no end to infinity. So again parentheses, this one is part of the solution, so you will put a bracket for it. Okay, let's do next one. This one is, this is how you read it. So -1 is less than x, and x is less than or equal to 3, or this is how I read it, x is more than -1 but less than or equal to 3. So when you graph it, its left endpoint is -1, and because there is no equal here, so you will leave it open, its right endpoint is 3, and you will fill it because it has the equal there, and then you will connect them. So this, all these points between -1 and 3 will be the solution for the inequality. Now how will we write this down in interval notation? So our left endpoint is -1, our right endpoint is 3. Then this is not part of the solution, so parentheses, this is part of the solution, so bracket. Okay. Then let's do backward practice. This one is, you have the interval notation and you are writing down the inequality and you are graphing it. So first let's graph it. Now its right endpoint, it doesn't have, it's infinity, and its left endpoint is -3. So this is our -3. Okay, now it's going towards it's going towards the positive infinity. So these are our positive, this is your positive infinity. So it will be going towards it, and one more thing, which is this bracket. When we have the bracket, that means it's a closed dot, so you fill it, okay? And how will we say it? We will say x is greater than or equal to -3. So how will you write down is greater than or equal to -3. So this is how you write down your inequality. Let's do next one. This one is its left endpoint is -2, which is here. Its right endpoint is 5, which is here. And then you decide, will you be filling them or not? So because this one is parentheses, that means it's not the solution. Since this is bracket, that means this is the solution. And then you connect them with a line, because everything between -2 and 5 is the solution for it. Now, how will we write this down? We will say x is more than -2 or greater than -2, but x is less than 5 and less than or equal to 5, because we filled it and there's a bracket. So there will be equal for this one, no equal for this one because this is a parenthesis. So this is how you write down the inequality. Okay. Now let's practice how you will write down the range for the domain and range using the interval notation. Okay. So remember, domain in the graph is nothing but the x values. Okay. So what you do is you find out what is the minimum x value, what is the maximum x value, and you write it down in interval notation, and that is your domain. So remember that domain are x values in the graph. So if you come up here, these are your x values. Okay. Then the minimum x value, so you come up here, this is the left end point of your graph. You find out what is this x value. Okay, it's -3. Now you come up here and you find out what is the maximum x value, and that is 6. So the domain for that will be -3 and 6. Now we need to decide, will we be putting a parenthesis or bracket for these? Now you can see there is a open dot here. That means -3 is not the solution. So parentheses. Here we will be putting a bracket because it's a closed dot. So this is the domain using interval notation. Now range is nothing but the y values. So you find out what is the minimum and maximum y value. These are the y values for your graph. So the lowest you have is -4 and the highest you have is 4. Okay. So we are going between -4 and 4. Now all we need to decide here is, are those filled or not? So you can see -4, so this endpoint is open for -4, so it's not the solution. And when you come here, it is a solid line, that means 4 is part of the solution, so you will be putting a bracket there. Okay. Now this one is asking, is it a function? And it is also asking us to write down the domain and range in interval notation for it. First, let's write down the domain and range, and then we will decide if it is a function or not. So again, domain is the x values, range is the y values. So these are your x values. So if you're writing down the domain for that, now you want to find out what is the lowest x value you have. But if you come here, you will see the arrow. That means it's not ending anywhere. It's constantly going. So it's going towards the negative infinity on this side, and it's going towards the positive infinity on this side. So the domain for that will be negative infinity to positive infinity. Now there are no endpoints for that infinity, so you just put parentheses. Okay. Now let's look at the y values. Then again, the function, its y values are on this axis. Now again, you notice the arrows. So it's going towards negative infinity on this side, positive infinity on that side. So again, its range will be negative to positive infinity with parentheses. Okay. Now let's do this one. And for this one, you can see the function is broken here. So it goes when x is 0, y value or function value is 2, but then also it's broken, and when x is 0, your y is also 0. Okay, so the function has two values there when x is 0, and it's a broken function. So when you have a broken function, you have to lift a pencil. It's not even a function anymore. So this one is not a function, first of all. Okay. And this one, you can see it is constantly going without lifting the pencil. There are no breaks in the function, and its curves are smooth, so they are not sharp turns. So this one is a function. Okay. Now let's talk about the domain and range. So for this one, the domain we will be writing in two parts. One will be going from here to here and then going from here to here, because you want to show that function is broken at x equals 0. So you will say, so this one, if you focus, this is your x equals 0 here, and then this is going towards negative infinity. So we will write down negative infinity and 0. Now it is a closed dot, so that, and this one will be parentheses. Now again, the function is picking up at x equals 0, so you will put it again. But this time you can see there is this arrow. That means it's going towards the positive infinity. So we will say infinity. So this is how you show that your function is broken, okay, using the interval notation. Let's find out the range. Okay. Now you can see that this is the lowest value it has on y-axis is a 0, which is right here, and if it goes up, it's going towards positive infinity. So we'll say it's going towards infinity. Now this one is covered in the range, so we don't need to write that down. So this is how you will say this one. Okay. Okay, one more. So here we are. This one is, it is asking us to give the domain and range in interval notation. So the domain again are the x values, and these are your x values. Okay. So you find out what is the lowest value and what is the highest value. You can see there is this arrow, that means it's not stopping anywhere. So it's going towards negative infinity. Now its right end point is nothing but 2. So we will say it's going between negative infinity and 2. Now this is always parentheses. This one is a open dot, that means that's not the solution to that. So we will put the parentheses. Now let's find out the range for it. Range is again the y values. These are your y values. So you can see that function is stabilized at this value. It's not going down, so it just stays here, and this one is your 1 2 3 4 5. So this is your -5. So -5 is your lowest range. Now let's find out what's happening here. 1 2 3 4 5. This is your higher range, so it's swinging between -5 and 5. So we will write down -5 and 5. Now this one is fixed, the values are part of the solution. Here you have open end point, so you will be putting a parenthesis there.